Okay, hello. Okay, let's solve examples on how to determine the moment of inertia of built-up sections or areas. Okay, composite areas. Alright, so na-kuhan ko to kanina, nagkamali ako. Anong erasure. Okay. Okay, so we have determined the moment of inertia of the cross-sectional area of the T-beam with respect to the x prime axis passing through the centroid of the cross section. Okay? Tinabad ako mag-print kaya iba yung nasulat ko dito. Don't mind yung erasure dyan. Okay, so we have the answer dito. We'll see if we will get the correct answer. Okay, so we are to determine the moment of inertia about the x prime axis. So and x prime axis passes through the centroid of the cross section. So nandito daw yung centroid. So nilagay ko na ng label. Centroid ng buong section nandyan. Nandyan din yung x prime axis. So basically we are solving for the IXO or the centroidal moment of inertia of the section about the x-axis. Moment of inertia about the centroidal x-axis, I should say. IXO. Moment of inertia about the centroidal x-axis. Okay, so dito yung ating centroid. Now, ang gawin natin para ma-solve yung moment of inertia, kailangan natin, so may moment of inertia, we have to divide yung section natin into regular sections, of course, ito. Ayan. Okay. And then, since yung centroid ng bawat section, ito din, ang centroid niya ay it doesn't coincide with x prime, then that means we are going to transfer yung centroid ng area 1 dito sa may centroid ng buong structure, buong section. And then we are also going to transfer yung center ng area 2 papunta dito sa may centroid ng buong section. So kung magkakatugma sana yan, pare-parehas yung location, i-add lang natin yung moment of inertia. Okay, we don't need to transfer or use the parallel axis theorem. But since hindi magkakatugma, they don't lie on the same point or line, then we have to use the parallel axis theorem. Okay, for that to happen, of course, kailangan nating malaman nasaan ba yung centroid nung section. So we have to determine yung y bar. Ito, y bar natin. So yung baseline natin ay nandito. Pwede rin naman dito yung reference axis natin. But since yung drawing ay nandito na, so we have to use ito na lang yung illustration. So we need to know kung nasaan yung center ng buong section from the base of the T-beam. Okay? So how do we solve for the centroid? So that was our previous topic, paano pag-solve ng centroid. So this time, i-diretso na natin yung solution, kasi sa previous examples natin, previous discussions, isa pa nating sinosolve yung area and the different items in the equation. So this time, i-diretso na natin, you can do that, no? I-diretso na natin yung solution. So what we need to know ay yung equation natin to solve for the centroid. So summation tuloy. Yung total area times y bar is equal to the summation of yung area ng individual areas times their distances from the centroid of each section or area to the reference axis. So in this case, y. So yung total area natin is itong dalawa. So area 1, area 2. Location ng centroid for area 1, location ng centroid for area 2, and this is the centroid for the entire section. So total area is 150. Yung area 1 natin is 150. I will no longer include the units para hindi masyadong mahaba yung equation. 150 times 30. Okay, that's area 1 plus area 2, that's another 150 times 30. So this is the total area times y bar, equals Let's start with area 1. Area 1 is 150 times 30 times yung distance between C1 and the baseline natin. So it's rectangle lang naman siya. So we have 30 divided by 2 is 15. No? Plus, ito naman. Area 2 natin is also 150 times 30 din. And then, ito yung C2 natin to our reference axis. So, C2, ano yan? 150 ito, ano? Divided by 2, that is 75. Plus 30, so that is 105 mm. Okay, so we can now solve for the location of the centroid from the base of the T-beam. Alright, so Y bar is 60 mm from itong reference axis natin. Okay? Next, since alam na natin yung location ng centroid ng buong section, yung IXO natin is equal to, i-transfer natin yung, since hindi magkakalinya yung centroid ng bawat section doon sa centroid ng buong structure. Ngayon, i-transfer natin, gamitin natin yung parallel axis theorem, i-transfer natin yung moment of inertia ng area 1 papunta dun sa axis natin dito. Ganun din ang gagawin natin dito sa area 2. Okay? I-transfer natin yung moment of inertia niya papunta dito sa may centroid ng buong structure or buong section. Okay? That's what we're going to do. So, IX ng area 1. IXO, I should say. IXO ng area 1. So, that is equal to, so ang IXO natin for rectangle, just to review, IXO is equal to BH cube all over 12. No, kapag centroidal moment of inertia ng bawat rectangular section is BH cube all over 12. Okay, so let's start with the first area. Base niya is 150. By the way, yung transfer formula natin, IO is equal to I plus AD squared. Okay? So, yun ba yun? Let me revisit. Yung transfer formula natin. IC plus AD squared. Yung centroidal moment of inertia ng section, okay, plus AD squared. Again, D squared dito ay yung distance between yung centroid ng area papunta dun sa centroid ng buong section. Okay? So, ito naman. So, let's start with the first area. B is 150, H is 30, cube all over 12, plus AD squared. Area ng first section, area niya is 150 times 30. Now, D squared is distance ng C1 to C. Okay. C1 to C. So, ano yung distance na yan? We know that Y bar here is 60 mm. Yung Y bar natin. So, distance between C1 to C is just Y bar minus yung kalahati nito. Okay, so that's 60 minus 15. Okay, 60 minus 15. That is equivalent to 45. 45 squared. So, AD squared yan. So, ito na yung ating na-transfer na moment of inertia ng area 1 papunta dun sa X prime axis. Okay, tapos na tayo sa area 1, na-transfer na natin. Next, yung area 2 naman ang i-transfer natin. So, BH cube, moment of inertia ng area 2, i-transfer natin dito sa may centroidal axis ng buong section. So, base natin is 30. Height is 150 all over 12 plus AD squared. So, area natin is 150 times 30. Now, ano naman yung D? So, C2 to C. Okay? C2 to C. Anong distance yan? So, we know that itong C2 papunta dito, ano ba? Ayan. Ayan, C2 papunta dito ay 105. Ano? We have 75 papunta dyan plus 30. So, 105 millimeters. Okay. What we need to know ay itong distance na to. Okay. Anong distance ito? Between C2 and C. Okay, paano yun? So, we have 105 minus Y bar. Okay, we do it by inspection. So, 105 minus Y bar is distance between C2 and C. So, ilan yun? So, 105 minus 60 yung Y bar natin. So, that is 45 squared. Yan. Okay, AD squared. Yan. So, okay na tayo. So, ma-complete na natin yung centroidal moment of inertia, no? Or moment of inertia about the centroidal x-axis, IXO, of this particular section. Okay, so the answer is, IXO is 27 times 10 raised to 6 millimeters to the fourth. Okay, so that's IXO. Yan yung hinihingi ng problem. Okay, so yung answer dito sa may na nailagay, sorry, typo ito. Answer to sa ibang problem. Okay, but that's not the answer for this particular problem. The answer is 27 times 10 raised to 6 millimeters to the fourth. So please ignore this one. Okay, so yeah, that's how we solve for the moment of inertia. Okay, about the centroidal x-axis. Now, sir, paano naman kapag centroidal y-axis? Okay, centroidal y-axis. Nasaan ba yung centroidal y-axis? Okay, since if you draw yung center line natin dito, ito yung center line natin, ano? Yung center line natin, yan. So, symmetrical naman relative to the center line. So, this is our YO. Okay, YO axis. Okay? So, if you try to extend this one, we can extend natin yan. Mapapansin ninyo na yung mga centers natin, yung center mismo ng ano, ng buong struct, ng buong section, yung center niyan, align dun sa center ng first na area, C1, naka-align din yan sa center ng second area. Okay. So, pag magkaka-align yung ating yung mga centers natin, there's no need to use for the transfer formula. You don't need to transfer. No. Unlike kasi dito, sa IXO, no, yung center nito, so horizontal kasi, horizontal axis, hindi magkaka-align. Nandito yung C2, nandito yung C1, nandito yung C ng buong section. So, that's why we have to transfer. So, pag magkaka-align na, we don't need to transfer. Okay? So, sige, kahit na hindi tiyatanong sa problem, isolve na lang natin. How about IYO? How do you solve for IYO? Paano naman solve yung IYO? Okay. So, i-add lang natin yung mga moment of inertia nila. Okay? So, for ito, rectangular section, ang IYO natin is B cube H all over 12. Baliktad lang natin yung may cube. This time, yung B ang may cube. Ano? So, B cube H all over 12. So, for section 1, so area 1 natin, B cube. Ang B natin is 150. H is 30 all over 12. So, baliktad natin to. Plus, sabi ko nila, we don't need to transfer. We need to apply the transfer formula or the parallel axis theorem. because magkaka-align na yung mga centers nila relative to the YO axis. Okay? Then, okay, next, ito naman. That is 30 cube. Yung second na area natin, ang base natin is 30, ano? So, yun ang i-cube natin. Times 150 height. Okay. So, ang IYO natin is equivalent to ilan? I-compute muna natin. 8.775, paki-check na lang, times 10 raised to 6 millimeters to the fourth. Okay. Ito yung IYO natin. Okay. So, ayan. So, I hope na klaro yung ating solution. Okay, let's have more examples sa next na video na lang muna.